Good morning, everybody. So, what I want to do today is for the ed puzzles for this final week of class, I'm going to go through a few formulas that I think are going to be very valuable for you guys to know for the final exam. We're trying to get ready for the final, right? And I understand there's a lot of material we've covered this semester, so what I hope to do today is the first video we're going to go through just a couple formulas I think would be useful to make yourself a formula sheet. So I'm going to go through and list these formulas out and talk a little bit about what they do. And then the next video is just going to be more of a generalized, here's what I would suggest in terms of getting ready for the final. But let's start with just some of the formulas that we've talked about, okay? Well, one that we're definitely going to want to take a look at is we're going to want to know the formulas, just working with linear equations, how you find the slope. So remember, to find the slope of a line, it's y2 minus y1 over x2 minus x1. Remember that this is the same formula that we use for the average rate of change. Now, it's written a little bit differently. y2, or f of b, minus y1 f of a over b minus a. But these are essentially the same formulas, right? The next formula we're definitely going to want to know is the difference quotient. And that is the f of x plus h minus the f of x over h. At that point, we kind of laid off of formulas for a while. We went and took a look at transformations of graph, things of that nature. Those are definitely things that you need to study. But there's not necessarily a formula for those different things. There might be some examples you want to put on your formula sheet. But you're allowed to have open notes for this test. So don't just, I would encourage you to rework some of your notes and clean them up a little bit. And this is part of that process, is to clean those up a little bit. I'm going to suggest that you go through and you make yourself a formula sheet that you kind of have out on the side and keep it handy so you can refer to those things. The next formula we really took a look at and worked with a lot were compound interest formulas. So there were two different ones we worked with. With the financial components, we talked about compounded n times per year. And the formula for that one was the amount in the account after some amount of time followed we took our initial amount, our principal, 1 plus our interest rate divided by the number of times compounded, raised to the nt power. Compounded continuously followed the formula, the amount after the certain amount of time is equal to the principal times e raised to the rt power. Please note that this is also pretty much the same for exponential growth and decay. And again, just whatever the, however much, whatever the population was after t is equal to, this we just used r. I think it might have been a k up here, it might be an r up here. But it's basically the same formula, but the one thing we wanted to remember is if it's an exponential decay, it has a negative rate because that is going to be decreasing over time. Okay? And then we really kind of picked up a couple formulas in the last week or so of class in terms of arithmetic sequences and geometric sequences. So arithmetic sequences, we found our equations were, so to find the nth term of an arithmetic sequence, what you do is you would say for the nth term it's equal to your first term plus the common difference and then n minus 1 times. To find the sum of the first n terms of an arithmetic sequence, we'll use the following. It's going to be, to find the sum of the first n terms, it will be n divided by 2, where n is the number of terms in our sequence, and then it would be the first term plus the last term. And then we had a couple formulas for geometric series. So for a geometric series, what we do there is to find the nth term, it is going to be our first term times r to the n minus 1 power, where r is our common ratio. Remember, we can calculate the common ratio by dividing the second term by the first term, or any two subsequent terms. The sum of the first n terms of a geometric series is given by the equation S of n is equal to a1 1 minus r to the n over 1 minus r. And then the last one is the sum of an infinite geometric series. So if a geometric series is converging, we can find the sum of an infinite geometric series and the sum of the infinite geometric series, I'll put a little infinity here for this one, it's going to be the first term over 1 minus r. So those are just some of the formulas that we used in this class. It's really not all that many, but it's going to be helpful to keep those handy when it comes time to take the final exam. So I would take some time to write these down, and once you get those written down, I would start to get those organized and keep those handy for you for when it's time to take the final.